This is Algebra 2, first day of notes. Many of these you should have an idea of what's going on. I just want to run over some of these. We're looking for the order of operations. So you're going to do parentheses with your grouping symbols. You're going to evaluate the exponents, multiply and divide, add and subtract. It's often considered PEMDAS. So we have 200 minus 2 times 9 squared. You do what's inside the parentheses first. Then you have to square it, which is 81. Then we multiply minus 162 divided by 3. We divide 3 into that, which goes in there 5 times, so it's 54. 3 goes into 16 5 times with 1 left over, goes into 12 4 times. And we can subtract that to be 146. Down here, if you're squaring a number without a parenthesis, you do not square the parenthesis. But if you're squaring a value with the parenthesis, 2 negatives make a positive. If you square a negative, you get a positive. So you get 25. Here we're going to evaluate when m is negative 4. So we plug in the negative 4. Again, you're squaring a negative in this case, so you get positive 16. Here we're going to get 48, negative 20 minus 12 more. So this comes out to be 28 minus 12, which comes out to be 16. In this case, we'll get 3 times negative 2 squared. The 2 is squaring the y. The y is negative 2. So the negative 2 is being squared. So it's 3 times 4. Many people will make the mistake and call that negative 6, which is incorrect. 2 negatives, when you multiply, make a positive. Down here, we're just collecting like terms. There's nothing to plug into it. There's nothing to solve for, so the only option is to collect like terms. When you collect like terms, they have to have the same variable, and they have to have the same exponent. 8 minus 9 gives you negative 1, so negative r cubed plus 6r squared. That's the best you could do. Here we distribute through to get 9t and a minus 36 minus 6t and a negative 42. Don't forget to distribute the negative. Nine minus 6 is 3, 36, negative 36, and a negative 42 gives us 78. Again, all we can do is collect like terms here. We have the 15a, the 8b, the 20a, 14b. We need to distribute here to get 5a squared minus 35b. Then we can bring the a's together to get negative 15a. Can bring the b's together to get 6b. There's no a squareds other than this one, so it stays 5a squared. And we still have these extra b's sitting down here. So the way we're going to write this final is to typically put your largest exponent first, so your square goes first. The letters that go with that, which is the a. Then our b's, we have a positive 6 of them, negative 35 of them, so that's negative 29b. Here, we're going to solve the equations. Now we're solving. We're going to simplify if we need to on the side. We're going to collect all variables, and then we're going to isolate the variable. So here, a couple different ways we could consider doing this. I like to multiply by the denominator. So I'm going to multiply by 3 to both sides to get rid of that denominator. And then divide by 2. That gets us 18. On this side, we would distribute. When you multiply here, you get 3 times 10, which will be 30, and 90. That can actually reduce down to 1/3. Let's see where else we're at. We're going to subtract. Let's see. We'll say 2/5 x plus 1/6 equals 3/10 x plus 1/3. What does, this is one way we can solve it, what does the 5, the 6, the 10, and the 3 all go into? They all go into 30. So I'm going to multiply all of these fractions by 30, and by doing that I can reduce the 5 and make the numerator a 6, reduce to make that a 5, to make that a 3, to make that a 10. So now I have 6 times 2x. So we'll call that 12x. We have 5 times 1, which is just 5. We have 3 times 3, which is 9x. And we have 10 times 1. That can help a lot in terms of getting rid of our denominators so we can solve. Minus the 5 and divide by 3. So I see that as 5/3. Here we'd have to distribute first. Distribute. 2 negatives make a positive, so very important that you notice that it's negative 3 times negative x is a positive 3x. 8 and 5 is 13. That's not my typical way to show what we're doing. We're going to subtract the 3 to the other side. Gives us 10x. We can add the 36 to the other side to give us 6. Divide by the 10, and x equals 3/5. On the second page. Okay. If you obtain an untrue statement, such as 6 equals 0 or 0 equals 6, then there's no solution. If you get a true statement, then you get all real solution. So in this case, when we're solving it, distribute. Here, they're unlike terms, so we can't call that 0. We can group those two together. When we minus the 18 and we add the 18x, we get 0 equals 0. So that's a true statement. 0 always equals 0. So we're going to get all real numbers. Here you cannot collect like terms because one has an x and one doesn't. So the best we can do is work there. Gives us 12x. And we can subtract the 12 over here. And add the 24 to this side. And we're going to get 0 equals 20. Or maybe you would say negative 4 equals, or negative 24 equals negative 4. And that also is not true. This has no solution. There is no value of x that's going to make both sides equal to each other. Next, we're going to look at a word problem. We're going to label the variable. We're going to write an equation. We're going to solve the equation. And always be sure you answer the question. The bill for your automobile repair was $265 and some change. The cost of the labor was $52 per hour. The cost for the material was $135 and some change. How many hours did the mechanic work on your automobile? So you're going to say that x is your unknown, and that's going to be the number of hours worked. Okay, he worked that many hours. So if he makes $52 for every hour, and there was an additional 135.74, which is the materials, and you got charged $265, we're going to subtract the 135. So those cross out completely. Those are going to cross out, get a 0. So 130. When we divide this by 52, we're going to figure out that x equals 2.5. So he worked 2.5 hours. Okay. We're going to solve linear inequalities. Linear means a line. Inequalities means it's going to have the little Pac-Man sign. We're going to reverse the symbol if we have to divide or multiply by a negative. Here we solve it just like it's an equal sign. 4x is less than 16. Divide by 4, and x is going to be less than 4. So here we come over here and we subtract the 3 perhaps. Is less than or equal to 6x minus 8. In this case, I'm going to subtract 6x. Get negative 2x. And when I divide by a negative 2, x, now we have to switch the sign. We've got to make it go the other way. Is greater than or equal to 4. Now we can do the same thing. It's called a compound inequality, but same idea. We have negative 10, 3x plus 5. That is this portion of the equation. Then we also have the other portion of the equation. The 3x plus 5 has to be less than or equal to 8. If it's sitting in the middle like that, we would expect this to be a segment. It's going to have 2 endpoints with values in between. Divide by 3, we have to be greater than negative 5. Three x is less than or equal to 3, so x has to be less than or equal to 1 when you divide by 3. So we're going to have a negative 5 down at this end, we're going to have a 1 up at that end, with 0 somewhere in the middle. So we're going to have a value, we have an open because it's only greater than, and we have a closed circle hollow because it can be equal to that amount. We're looking at all the values that are less than or equal to 1 but are greater than 5. On this one here, it has an OR, so I'm expecting an arrow to go to the right, an arrow to go to the left, and nothing to be in the middle. It might overlap or it might just have a gap. We'll have to see how this one works out. So we divide by 2. You don't have to switch the sign here because we weren't dividing by the negative. We got a negative answer, but we weren't dividing by a negative. So here we're going to have a -3 down on this end and a 1 down on this end, 0 somewhere in the middle. X has to be less than or equal to, which means it gets shaded in to the left. It's got to be greater than or equal to the 1. Our last question is at the top of the next page. We'll run through some of these. So, or we're expecting it to go in opposite directions. Here we're going to divide by a negative, so we have to switch the sign. Alright, it's plusing 7. That's not, so we're up at 30. That'll go in there so much nicer. And when we divide by a negative, we have to switch the sign to get -6. And if we were going to graph these, you would see that we're greater than -2, but we're less than -6. Greater than or equal to -2, but we're less than -6. So it's hollow because there's no line underneath it. Last one. We're going to work on this problem, then we're going to work on that problem. So we'll add 2 to both sides. Multiply by the denominator. So we're going to multiply by 3. Multiply by the denominator, so we're multiplying by 3. So again, we have to be greater than -3. We have to be less than 18. So we'd have 18 over here, -3 on this side, just 3, not 13. With 0 somewhere in the middle. We're going to be greater than -3, but we're going to be less than, so it's shaded in, -18. That's the first day of notes.